Welcome to the session on setting up community edition for Databricks. Since AWS Glue is not included in the free tier, it's good to learn and practice Pyspark in the community edition of Databricks. To set up the community edition, just go to the Google and type Databricks. Click on this link that is coming up first, which is databricks.com. Fill up all the relevant details that is required to set up the Databricks. I pause the video for a minute as I am going to fill up this information. You've got two options available. So this is for the business purpose and the community edition is for student purpose. So we will use the community edition. In the community edition, we will be getting only a single cluster about 6 GB and no worker nodes. We have a basic notebook without collaboration and limited to 3 max users. It's a public environment to share your work. This community edition is good enough for us to learn Pyspark. Let's get it started. Once you click on Get Started, you will be getting an email for signing up. I'll be going and checking my email box and clicking on Sign Up for this tutorial. I'm logging into my email. I got the email for the Databricks verification. I'll be clicking on this to sign in back to the Databricks. I'll be setting up a new password. Once I've set up the new password, I'll be logged in like this. This is how you will set up the community edition for Databricks. In the next lecture, we'll look into how to load the data inside Databricks. Welcome back. In this session, we are going to load the data inside Databricks. Before loading the data, let's start the clusters first. In the left-hand side, click on the clusters menu. Click on Create Cluster button. Give a name to the cluster. I am choosing the Databricks runtime version 6.4. There are various runtime versions available inside Databricks. Click on Create Cluster. It takes few minutes to create the cluster inside Databricks. I will pause the video for a minute until cluster being created. Welcome back. The cluster got created. Let's add the data inside Databricks. Click on Data menu in the left-hand side. Already a default database being created. Let's add the data. There are various options available to load the data inside Databricks. I am going to upload a file inside Databricks. Click on Browse. Choose the file from your local system. Click on Create Table with UI. You need to select a cluster to preview the table. Let's select the cluster. Now click on Preview Table. Databricks on its own chooses the table name. Let's edit the table name. We're going to give it as sales records. It is a CSV format. The first row is a header. We ask the Databricks to infer the schema, then click on Create Table. Now the table is being created. Let's query the table in the notebook. Go to the Home, click on New Notebook. Give the notebook name as Test. Let's run this command. Then we'll put a show to see the records whether being loaded or not. In this command, we are going to execute a SQL query using the SQL context object, selecting from the table which we created right now into the data frame. Shift plus enter to run this command. You could see now the data being loaded inside Databricks, and we are able to query the data inside the notebook. Welcome to the session on Data Frame Basics. Let's get it started by loading the data in the data frame from the table which we already loaded the data inside Databricks. We're going to use SQL context .SQL to execute a command to load the data into data frame. SQL context is the main entry point for data frame and SQL commands. Let's run this command. You can run this command by pressing Shift and Enter together. Now the command got executed. You have another option to run this command by running from the right hand side using the Run Cell option. Let's look into various commands to query the data from the data frame. Let's use the first command, head. So we are going to do data frame object.head, and this is a method. Use Shift and Enter to run this command. Let's analyze the results. As we see, the output is nothing but a row object which contains the details. So currently this is returning only one row. So let's return the 5 rows by putting an integer value inside the head method. This time I'm going to run from the right hand side run cell. Now the output contains 5 values. Let's look into the another command, take data frame dot takeoff, and this time we'll give it straight away 5 rows. I'm going to use Shift plus Enter to run this command. If you see the output, both the output of take and head remain the same. Take is another option of querying the data from the data frame. It is also returning the row objects. Let's take the first value from the data frame by using the function dataframe.first. I'm going to use Shift plus Enter to run this command. The output contains only one row as it returns the first value of the data frame. Ensure that sort method is being applied in the data frame to return the same values when you query the first method if the data is being distributed to different clusters. Let's look into the last option, show method. Show method is the most widely used option as it displays the data in more readable format. If you see the output, we can be able to read the data more easily compared to the 3 options that we have used. One thing to notice is show method doesn't return the output in the row object. Welcome to the session on data frame basics. We are going to do some basic operations on the data frame that we usually do once the data is being loaded in the data frame. For example, in a business case scenario, once the data got loaded into data frame, we would like to see the schema, the list of columns that is present, and then sometimes the customer wants to change the column names. So we will execute renaming the columns. Let's look into the demo for those scenarios. Let's load the data into the data frame by running the command SQL context.sql. As we already discussed, SQL context is the entry point for your data frame and SQL based queries. I'm going to do the run cell operation. Now the data got loaded into the data frame. The first operation we are going to do is to see the schema of the data frame. So to see the schema of the data frame, we are going to use df dot print schema. It is a function. So, and I'm going to do shift plus enter to run this command. As we see, we are able to the schema and the list of columns and the data type, whether it is a nullable value or not. Once we load the data and we see the schema, we want to see sometimes the list of columns only, what is being present. Even though print schema gives a list of columns along with the data type and all, sometimes we want to see only column name. We'll be doing this operation by doing data frame dot columns. Now you could see we are able to see the list of columns available in the data frame. Now let's move forward and rename this column. For example, the region doesn't give me a meaning, so I'll give this region name rather than a region. Let's do this rename of column. We'll use with column renamed function, and we'll give the column name of the old one, which is nothing but the region, and give the new column name, which is nothing but the region name. I have a question now. In Pyspark, whether is it possible to change the list of operations? What it means is, I executed a command with column renamed. Once a command got executed, or once a function got executed, now I want to print the list of columns to see whether the column got changed or not. Usually in SQL and kind of queries, what we came across, what we do here is we execute the first command and then we execute the second command. But in Pyspark, we can chain the list of commands together and execute it together. For example, I can put a dot and I can add another operation, which is nothing but printing the columns using the columns. What it happens here is, the first operation will get executed and renames a column from region to region name. Then it will print the list of columns available in the data frame. Let's check into the results. You could see here, now both the operation got executed together. So the first operation converted region to region name, and then we are printing the list of columns. We are able to see the region to region name got changed. So in Pyspark, we can reduce the lines of code by chaining the operations together. Now let's look into another way of renaming the column by using a select expression from the data frame. This is similar to a select operation you usually do in a SQL statement, where select column name as the new column name. As we know already, in the select expression, whatever column name you are giving, only those column names will be renamed and it will be provided in the output. Again, we see we are chaining the operation, the show method, after the select expression to see the results. You could see the output contains only one column as given in the select expression, and the column name got renamed. Now, I have another question. We renamed the column in both the operations. One, we renamed the column with column renamed, and we renamed the column using select expression. Suppose if I go back and see the list of columns that is present in the data frame, whether the column rename operation that whatever we have did will it get reflected? Let's take a look at it. Again, we are going back and saying df.columns to see the list of columns that is present in the data frame. Okay, now we see even though we executed these operations with column renamed or select expression, actually the column name is not getting changed in the original data frame. Why is it so? The reason is we are just executing the operation but not storing back to the variable. So usually remember this in Pyspark. If we execute the operation, if we are not storing back to the variable, so that operations, whatever we executed, will end with the statement itself. Now let's go back and assign that value once a column rename has happened, assign back to the data frame. Again, we are executing this statement, and I am going to use run cell operation to run this command. It got executed. Now we are coming back and executing the list of columns to see whether the column name actually got changed or not. We made a mistake here. What has happened here is, here in the data frame, we are actually, after that column rename, we are printing the column and actually stored back to the data frame. So that is the reason it is saying that list object is no attribute on columns. Further to fix it, we are going to go back and rerun this again. Reload the data into the data frame. Then we are going to come down. Here we are going to remove this chain operation. We are just going to do only the renaming of column and assign back to the data frame. It got executed. Now we are going to run this command, see the list of columns. Now you could see the region got changed to region name. Also, there will be cases where we need to add a new column from an existing column rather than renaming the column. So in this case, let's add the column region back from the region name in the data frame. But this time we are going to add a new column with a name called region. For this, we are used data frame dot with column is the function. In this, we are going to give the region is the name. This is a new column we want to create, and this has to be created from the existing column called region name. So I'm going to use df function. So to indicate from the data frame, use a column called region name and create a new column region and put those values. I'm going to assign back to the df to make sure that it is getting assigned back. Let execute this run cell. Now it got executed. Let's go and print these values. For that, we are going to have df.columns. Now you could see region name is also present and region column is also present. Welcome to the session on working with columns. Let's create a new notebook and give the name called column. Ensure that the cluster is there, available and running. If not, please go to the clusters menu and start the new cluster before creating the notebook. Let's create the notebook. Once a notebook got created, the first step is to load the data into data frame. Now the data got loaded into the data frame. In this session, we are going to see how to refer columns in the select statement of the data frame. Before going there, let's look into the print schema to see the list of columns on the data types. We are going to use the column total profit for our examples. There are three types of referring columns inside the select statement of the data frame. The first one is called canonical version. In the canonical version, we will use as a dictionary object of the columns. Let's deep dive into an example. Let's type the data frame and do the select. In the data frame, take the column as a dictionary, like total profit taken as a dictionary. And then we are going to change the operations and we are going to see show method being used. We see the output. One benefit of using canonical method is you can replace the column name at runtime. The second type is dot version. The main purpose of using dot version is you can do runtime calculations on the integer and double data types. Let's look at an example. We are going to do a df.select. This time we are going to use the dot version. We already have the column name, and then we are going to use show method to return the result sets. You can see the output remains the same both for canonical and the dot version. As I said before, in the dot version, you can do runtime calculations. Let's do a calculation by adding 10 to the existing value. You could see we can able to do a runtime calculation on the integers and the double data types. Now let's look into the third version of referring columns inside select statement. In this example, we are going to refer the column name directly and click on show. As we see, there are three ways of referring column names inside the select statement. One is on the canonical way, where we give the column name inside dictionary object. The second one is the dot operation, where we can do runtime calculations on top of it. The third version is directly using the column name. Let's look into another example of adding a constant string to the output of a column. For this, let's import call, late, and concat from the SQL functions. Now I'm going to use concat function inside the select to concat a string. The first parameter for the concat function is a literal value. I'm going to use as a test. The second value would be the column name, which is df. I'm going to use total profit. I'm going to use show method to see the results. You could see test has been taken as a column rather than a string. When you are working with a DSL, you should specify the string as a literal. Otherwise, Spark will try to take it as a column. Let's add the literal function to the string. Otherwise, Spark doesn't know whether it is a literal or string. Let's run this command again. Now we got test appended to the output value for the column total profit. Welcome to the session for the filter operation in data frame. Let's get it started. Let's create a new notebook. I am going to give a name called filter operation. I already have the cluster running. Once the notebook got created, let's load the data in data frame. Now the data got loaded in the data frame. I am going to see the list of columns in the data frame by using df.columns. Data frame filter operation is similar to the where query operation that we do usually in SQL. Now I'm going to filter the data where total profit is greater than 1000. df.filter, I use double quotes, total profit greater than 1000. I'm going to show this in the output. We got these records filtered out for this condition. I am going to use the select statement to only see the two columns, region and country. Let's run this. So I missed the closing bracket. Let's put the closing bracket and rerun again. We got two columns, region and country, for the condition total profit greater than 1000. Let's add one more condition where we want to see the records where the total profit is in between 1000 and 10,000. And I'm going to add the and condition. Let's run this query. You could see now the output contains the records which fulfills this condition. Now I'm going to use the dot notation column syntax in the filter operation. df dot filter df dot, I'm going to use the total profit greater than 1000, and I'm going to select only the two columns. And I'm going to do the show. Again, I missed to close the bracket. Let's rerun again. Let's add another condition where total profit is less than 10,000. I'm going to use the same condition. In the dot syntax. Let's see what happens. Okay, we are getting an error. What the suggestion was to use the and symbol for and, not the syntax what we have used. Let's replace the value of and with the and symbol and rerun again. Again, we ended up into an error. This error message doesn't give me any information how to fix the issue. When you are getting this kind of error messages while putting two conditions, make sure that you put parentheses in front of each condition, which solves the problem. Let's add the parentheses. Make sure that you give enough space between the two conditions. Now we got the results. With SQL kind of syntax, we can use a AND operator to combine the filter queries. With dot notation column, we need to use and symbol to combine the filter queries. Welcome back. Let's look into a demo. How to use sorting for the columns in the data frame. As usual, let's load the data in the data frame. Once the data got loaded, let's see the distinct values of total profit column. I'm going to select the column total profit. And I'm going to use a distinct function to see the distinct values of the column. And I'm going to show it. Now I'm going to filter the records so that we can see the sorting more clearly. For that, I'm going to use df.filter, where I want to filter the records based on total profit. I'm going to select only few columns. Which is total profit and country, and I'm going to show the records. Now we got around 6 rows, which is good enough to see how sorting works in the dataset. Before we go into sorting the column, let's assign the values back to a data frame variable. There are two methods available to do sorting in the data frame. One is sort function, another one is the order by function. Let's look into some examples. Let's use sort function for this one. So we have already loaded the data into a data frame 1 dot sort, and the column we are going to sort is total profit, and we are going to use ascending, and then we are going to show the data. We get an error. Ascending is not an attribute, it's a method. So let's do a method and do the rerun again. Now you could see the sort has happened for the total profit column. Let's look into another example of doing sorting for multiple columns. In this, I'm going to use the data frame df1. I am going to add 2 columns. One is country and total profit. I'm going to do a ascending. If you look at the syntax is a bit different from the syntax what we used before. In this dot notation, we used the ascending function. In this case, we are using a canonical form, and we are having 2 parameters. The first parameter contains a list of columns in the order by function, and the second parameter to say whether it is an ascending or descending. If you look at the second parameter closely, it says ascending of 0, 1. What does it mean is the first column ascending is false, the second column ascending is true. Let's run this. You could see we are getting an output total profit, which is a descending because the first parameter we said ascending is false. So the column got sorted in the descending order. Let's make it as 1 to see the difference. Now we are saying that ascending is true for the first column After the first column is sorted, the second column country is sorted based on the first column. Now you could see the values got sorted in the ascending order. Let's look into another way of sorting the column. Again, this is single column sorting where dfn.sort. You can use ascending function at the front and give the column name and do the show. So this is not defined. The reason is we have to import the SQL functions. Let's do this. Let's rerun again. Now we could see it has been sorted. So there are three ways of doing sorting in Pyspark. One, you can use two functions, sort or order by based on the choice you want to make. You can have the ascending function at the end or at the beginning by importing SQL functions import star, or you can do a multi-column sorting by using the order by function, having the dictionary object the list of columns you want to mention, and also the ascending or descending. Welcome to the session, how to do aggregation using group by function. I have already loaded the data in the data frame. Let's do a print schema on this data frame. Let me do a group by operation for the column item type. When I click on enter, I'm getting the output as a data type group data. Let me do a sum operation. Now the output I'm getting is a data frame. Now let me do a show to see the results. When analyzing the results, we see that all the columns which has a data type of integer and double shown up in the results. Now, if I want to do the operation for only one column, I have to put the column name inside the function. Inside the sum function, let me add a column name unit sold. Suppose you want to add one more column, you can put a comma and do that. As usual, now let's look into another syntax. How do we do aggregation? I'm going to use an add function, df.agg. This function takes a dictionary object. I'm going to do a dictionary object. The first value is the column name. I'm going to do the column name as item type. And I want to do a sum. Let's see what is the output of it. So it comes as a data frame, and let's see the show. Let's do the show operation. Since item type is a string, the sum is showing as a null output. So let's go for the integer values, which is unit sold, and replace this with. Yes, we are able to see the sum. Interestingly, if you would have noticed, we haven't done a group by operation on the aggregation. There are some scenarios where you want to do aggregation for the entire data set without grouping by, then this is the syntax to use it. Suppose we can do other functions like average. We can do a max. If you want to do aggregation on top of the group data using aggregation function, first use the group by and then use the aggregation function. Let's do this. So we'll group by item type. And then we do the aggregation function. And then we are doing the aggregation. So it's a dictionary. So let's change it to dictionary. Then we have units sold. Is the column name. And then we want to do a sum. We can use another column name, which could be total cost. And we do the average. And let's print it out. Now we are able to get the output for the item type, what is the average total cost, and what are the sum of units sold. Even there is another way of doing aggregation. Let's import SQL.functions from few classes, count, district, and average. We are going to use average inside the select statement itself. Let's do it. tf dot, we are going to select. While selecting itself, we can do an average for the column name total cost. And do a print of show. You could see we are able to get the output for the total cost. Welcome to the session on how to use joins in the Pyspark. In this session, let's load the data first into the data frame. Let's do the print schema. For we have to work on joins, we need to have at least 2 data frames. So what we are trying to do here is, let's filter out one record from the main data frame and create another data frame. Now the second data frame, the df1, which we created, will contain only one row. Now let's do the join in the data frame. The syntax is, so you have to use the data frame, the one which we created initially with the select star from the table name, and we use a join condition. We are giving the second data frame and what condition you are joining. I'm joining based on order ID and how I want to join. It is an inner join or left join or right join. We have to tell. Once you apply this condition, then the output will be shown in the results. So let's start with the inner join. Inner join is if both the records in the data frame is matching, then the output will be shown. In this case, we have only one row matching between 2 data frames and it will be shown in the output. Let's run it. Only one row got output. Now we use the right join. Right join is same as the left join operation, but performed on the right hand side data frame. In this case, df1. So what happens is, it will give only the right hand rows first, the data frame, and the left hand data rows, if it is matching, it will give you a value or it will show null. So in this case, what is the right hand data frame? df1, which is present inside the join, is the right data frame and df is the left data frame. So in this case, the output must contain only one row as df1 will contain only one row. Let's run this. You could see the output is containing only one row. When you make it to left, then the output should contain multiple rows. As df will contain a lot of rows, it has to output the lot of rows. Let's run it. Now, the difference between left join and right join is the left join, the left hand side data frame will be provided with all the rows and the matching records will be given in the right hand side. Where in the case of right data frame, the right hand side data frame will be provided with all the rows and the matching records will be joined with the left. If there are no matching records, then null values will be displayed. Now we have looked into inner join, left join, right join. Let's look into outer join. Outer join is nothing but a Cartesian product. So it will join both the data frames. Outer join combines data from both the data frames irrespective of on-column matches or not. If there is a match combined, one row is created. If there is no match, missing columns for that row are filled with null. Now let's look into left semi-join. So left semi-join is nothing but an inner join, but only the left data frame columns and values are selected. Let's look at it. Left underscore semi. In this case, it acts like an inner join, but only one row is selected. But if you go to the inner join, you see a difference here, the number of columns displayed. So it displays both the data frames columns and it is repeating it. But in the case of left semi, it acts like an inner join, but only left hand side data frame columns will be displayed. Left anti-join. This join is like difference between the two data frames. For example, it selects the rows from the data frame df that are not present in the data frame df1. Let's do the left anti. Let's run this. So df has around 94 to 95 rows and df1 is having only one row. In the left anti, that one row is eliminated and the remaining rows are shown. Let's do a reverse of df1 and we make it to df. What is happening here is df1 is containing only one row and df is containing 94 rows. But there is no records that is present in df1 which is not present in df. So we will get a null output.